Hey guys, welcome back to my YouTube channel. So in this video, I'll be doing an example of a expectation of sums of random variables problem in probability. A car breaks down at a point X that is uniformly distributed on a highway of length L. At the time it breaks down, a tow truck is at location Y that is uniformly distributed on the road. Assuming X and Y are independent, find the expected distance between the tow truck and the breakdown point. This is an example of an expectation of sums of random variables. So this is an expectation of sums of random variables of a continuous case. So let me write down the formula for a continuous case. So let's denote the expectation of g of x, y is equal to the integral of negative infinity to infinity, another integral of negative infinity to infinity, g of x, y, f of x, y, dx, dy. And we're supposing that x and y are random variables and g is a function of two variables. And if x and y have joint probability density functions, f of x, y, then it's this formula right here. So first, let me write down the joint density function of x and y for this problem. So it would be f of x, y is equal to 1 over L squared, where x is between 0 and L, and y is also between 0 and L. But first we need to find the distance between the tow truck and the breakdown point, or in other words, the expected distance. So we would denote it as the expected distance, or the value between x and y. So it would be the absolute value of x minus y. So based on the formula, let me write it down. So we would denote E, absolute value of x minus y, is equal to 1 over L squared, the integral of 0 to L, another 0 to L, of x minus y dy dx. Or in other words, we could write this as, so the integral is 0 to L of x minus y dy is equal to the integral of 0 to x minus y dy plus the integral of x to L y minus x dy. So first let me work with the integral of x minus y dy. That would just be xy minus y squared over 2. And now let me plug in x. So f of x would be x squared minus x squared over 2. And also, let me denote f of 0, which is just 0 squared minus 0 squared over 2. We take these two, we get x squared over 2. And now let me work with the next integral, which is y minus x. So let me do y minus x dy. This is just y squared over 2 minus xy. And let me plug in the boundaries for that. So that would be f of L is equal to L squared over 2 minus XL. And f of x would be x squared over 2 minus x squared. We take these. We would get L squared over 2 minus XL minus x squared over 2 plus x squared. And simplifying, when we add the xy minus x squared, y squared over 2 plus L squared over 2 minus XL minus x squared over 2 plus x squared, we would get L squared over 2 plus x squared minus XL. Now we have to do the integral one more time with the dx, in terms of dx. So that would be 1 over L squared over 0 to L of L squared over 2 plus x squared minus XL dx. Let me take the integral one more time, and let's do work with the dx. So L squared over 2 plus x squared minus XL dx. And that would just be XL squared over 2 plus x cubed over 3 minus x squared L over 2. And taking the boundaries, let's take f of L. That would be L cubed over 2 plus L cubed over 3 minus L cubed over 2. We say we get L squared, or L cubed over 3. And f of 0 would just be 0. And when we subtract that, we will get L cubed over 3. But we have to make sure we multiply this by L squared. So this would just be L over 3. So really the answer is L over 3. So the expected distance between the tow truck and the breakdown point is L over 3. And this is an example of an expectation of sums of random variables problem in probability.